Okay, this is me. This is what you can get from Fiverr if you pay $5 to have someone draw your picture. So my name is Johannes Ridderstedt. I am the founder of this meetup, Uppsala Tech Meetup. I'm also the founder of a startup here in Uppsala called 46 Elks. But I'm also a programmer. And tonight I am here to talk about Elm. I'll try to give you a proper introduction to Elm. The backstory is a bit funny. I was in Barcelona on an Elixir hack night. And that turned into a Elm crash course. This was in November 2016. And big thanks to Oliver for teaching me Elm back then. Really inspired me to learn more about Elm. So meetups can really be inspiring. And what is Elm is, of course, the question everybody's asking. This is the description from the Elm website. A delightful language for reliable web apps. Generate JavaScript with great performance and no runtime exceptions. So the short answer is, this is roughly the case. Here's a Hello World webpage. Plain HTML. As you can guess, here's a H1 tag. We have a P tag here, a paragraph. The HTML code looks like this. We've encapsulated our content in a div tag, and we have H1 with a hello world, and we have a P tag with this is plain HTML. The equivalent of this in Elm looks like this. So we say we import the HTML module, and we expose all the functions within the HTML module. And then we have our main function. So this is a function. And the purpose of the main function in Elm is to return the HTML nodes of your application, the look of your application. So what we are seeing here on screen is a function call to the function div that comes from the HTML module. And it takes two arguments. One is a list of attributes. The other is a list of children here. So here's the start of the list and the end of the list. Now, going into the children, we have a function call to the function h1 here. No attributes, so a list of no attributes. And then a list of children here. And this h1 actually has one child, which is an HTML node of type text. So this is a function call to the text with a hello world string as argument that returns an HTML node which is just a text node, and that becomes a single child in the h1. Then we have a P function call, no attributes, and one child there, which is the this is Elm text. A few even simpler examples. So here we have a super small Elm application. It's a main function, no arguments, and it calls the HR function, no attributes, no children. So a HR, horizontal ruler. It's just this horizontal line you've seen sometimes. Not used very often in HTML5, but in older websites it was a good way to divide content. Here, main function, simple image. We do have an attribute here. So the source attribute, calling the source function, returning an HTML attribute here in the list of attributes. And the first argument there is the URL to the image. No children. And here's a simple H1 example. And what you're seeing here is there's no return here before. Because in functional programming, generally, there are a lot of returns. The whole purpose of each function is to return with the expression executed of that function. So basically, you could put a return here in front of all. So here are two other non-main functions. Here's a function called seconds. It takes one argument, hours, and it returns hours times 60 times 60. So the amount of seconds for so many hours you specify. So if you put in 1, you'll get 3,600 back, which is the number of seconds in 1 hour. Here's a slightly more advanced function, speeding. Takes one argument, speed. And then we have if statement. If speed is above 120, which is the speed limit on some places in the highway here in Sweden. If it's above 120 kilometers per hour, then return true, else return false. And when you're having an if statement in Elm, you need to have an else as well. Because the purpose of this function is to return something. You can't skip the else. You have to specify what's going to be returned if this expression is not true. So what you learned is actually Elm is for the web, and it's a functional programming language. I'll show you some more. So here's a simple string, Uppsala, Sweden. And the recommended syntax when you're programming in Elm, when you're putting things in the top namespace, in the module namespace, is that you put the body of your function in the line below the definition of the function. So the location here is actually a function with no arguments, and it's returning the string Uppsala, Sweden. So basically everything in Elm is a function. Here is a function to do, returning a list with 3 fun stuff to do. Attend meetup, join Slack, have fun. And as you can see here, the commas are put not at the end of the line, but in the beginning of the line. This is also recommended Elm syntax. And why is that? It's to have clean diffs. So when you're adding a new line here, you don't need to change another line with a comma, or add a comma, or remove a comma. So the diff, if you add another thing like talk to people, it will be a comma, talk to people, and the diff will be very clean. Elm is also strictly typed and has typing inference. What does that mean? Here we have input function, which will return the string 100, the value 100, but within a string. Age is an integer with a value 34. So when we define the function here is correct, no arguments, we can access these 2 functions, input and age, because they are available here in the global scope. We will get an error because we're trying to compare a string with an integer. And for anybody who's used a typed programming language, this sounds very common and obvious. But type inference here means we're not specifying the types here in the top. But because of how these values are being used, the Elm compiler can figure out what types are being used and whether you're trying to use an incorrect type at an incorrect place. Yes?
So input up there, that's a function, right?
This is a function returning the string 100.
You don't have variables?
No.
Huh.
So let's see what the next slide is. Yeah, so continuing on strictly typed and type inference. Here's a main function, returning a div, no attributes, a list of children here. A second child is a P, simple one, epic fail. But the first child here is calling the function title with the argument 2018. Looking at the title function here, it takes one argument, t here. And the title function calls the function age1, no attributes, and the list of children is one child, which is the result of a call to the text function. And the text function always takes a string as argument here. So because this function takes a string as argument, the argument for the title function is also a string, because that is inferred. Which means when we're trying to call title down here with an integer, we get a compilation error. And this is also the reason why you want to have strictly typing and type inference, in order to catch these things during compile time instead of getting runtime JavaScript errors. Here is a slightly more advanced example. It's a list of, so it's an unformed list with 4 characteristics of Elm: functional, web-based, pure, delightful. Here is the Elm code for this example. So first we're importing the HTML module. In this case we're specifying the functions we're exposing, the UL, li, and text. We have our main function here, no arguments, and with the unordered list, no attributes, and here we're calling a function called children, and we're using the result of that function as children. And looking at this program, we can understand that children is not coming from the HTML module. So it actually has to be defined. So this is a broken example right now. Children has to be there somewhere. So here is children. We're calling a function called list.map, and then with two arguments, item and items. The purpose of list.map is to call the function item for each item in the list as the second argument. So we will call item on each item in the items list, and it will return a list of the results. And as we can see here, because of type inference, the children here should be a list of HTML nodes. So the item function should return an HTML node in this case. But obviously, how can we have list.map here? We're not importing it. And we're lacking item and items. Item and items are I'll probably show them to you soon. But list.map there. Well, so there's a list of default imports in Elm. So you have a basics module, so everything from there is exposed, and it doesn't contain that much, but it does contain things like toString, which converts an integer to a string, and a few of those functions. But most of the functions that are imported by default, they are imported with the module as a prefix. So you have to write list.map or string.x. Back to the code. Here is the item function, which returns a list of these properties: functional, web focused, pure, and delightful. And here's the item function. It takes one argument, a string, and then it returns the return value of a function called to li, no attributes, list of children, one child, calling the text function with a string as argument with the item. So here's the full source code. Maybe we can tweak it, we'll see. But there's just a simple import there in the top. No worry. Yeah, so this is the full source code of that program. Main function calling UL with the children. Children here is the list.map item items. And suddenly we have 4 things defined here in the global scope of this module. And it's not very nice to pollute your namespace of the module if there's no reason for other parts of your program to access that. So what you do is you define a local namespace for your function with a let keyword here, and you define labels here that can be used only within the scope of the function. So in this case, item and children are not accessible outside of the main function. Items, though, is defined on the global level, because maybe we want to use these items elsewhere in our code. And the obvious question is, of course, can't you write this whole program on a single line? And you can. This is how it looks. Not very delightful, but it does work. It generates the same output. But what's interesting in this code example, so I'll structure it a bit, is here, \s. So we're actually defining an anonymous function here that takes one argument, s, and then it uses that. This is the same code, but written in a different way, and not very delightful to not use any labels. So this is a more delightful way to write it. So how do you run your Elm applications? If you are a JavaScript developer, you probably have Node and npm installed, so you can just npm install -g Elm. There are also packages you can download from elmlang.org. And how do you run your code? Well, you create a folder, you create some Elm source files, and you run Elm Reactor. This fires up a browser on port 8000. And when you access that browser, it will list your files. And you can just click on the source file you want to run, and it will compile it, show any errors, in the web browser or show the result if it does compile. So that's the way you do it when you're developing. Okay, so how do you do it in production? You run Elm make your source file. It generates an index.html that contains everything, and you can just push that out. If you build a standalone Elm application, that works fine. If you want to embed your Elm application in an existing project, and that is the recommended way, if not when you're playing with Elm and you're starting to learn Elm, but when you're integrating it in your company. Let's say you're at Caspeco and you want to build some small part in Elm. Embedding it in another application is the way to go, because then you don't need to rebuild your whole software in Elm. Then you use Elm make source file --output and a app.js, for instance. And then you can embed that JS file in your existing applications. How do you do that? You have some kind of element in your DOM, in this case div id Elm app. You include your JavaScript file app.js, and then you fetch the element from the DOM, and you embed by writing Elm dot and then the module name, and the default module name is main dot embed, and then your node that you fetched from the DOM. So in this case, you can build a small thing and build a part of your application in Elm. And app.js includes everything for the app. So the Elm runtime is not included separately. And why is that? Because when you're compiling your code, you're building it with a specific version of Elm, and it's pure and functional. You want it to behave exactly the same way as you compiled it and built it. So you don't have the Elm runtime separately from your bundle, your build. And actually, only the parts of the Elm runtime that is being required by your application is actually going to be embedded. So it's a standalone bundle that is just executable with JavaScript. Yep.
So what if you already had one Elm name? It seems to put itself in a global namespace, in a global scope.
Yeah, it's. I don't know exactly how you can do that. I think you can probably specify the namespace, but probably what you want to do is you bundle those in together. So you only have one app.js, but it could be multiple apps. So you see here, elm.main, you could have multiple modules in that bundle.
I was kind of thinking that you pitched that you could include a portion like the Caspeco website to just use Elm. What if they already had them?
What
if they already had them in the scope?
Like
and you just
two parts, two Elm modules built by separate people.
Yeah, so the question is, if you had two modules built by separate people, you could still build them into one bundle and include that. I think that is the recommended way to go. But you can probably scope them and have them separately. It's going to be a bigger payload in your application. Maybe that's more feasible. It's certainly doable, but I haven't looked exactly into how you do that. Yes?
The app.js thing supports incremental rebuild on reload, perhaps.
Incremental rebuild and reload. So Shane?
Well, rebuild.
Can you repeat the question?
If you reload the page, or if you reload the JS link, rebuild, will it make sure that it's up to date?
So this app.js is just like any other JavaScript file. If you built it, if you have a deploy process, you probably want to have the name of the JS file hash based on the checksum of the file in your build process. Maybe you want to use Webpack or other software for that. This is out of scope for this talk. Okay. Yes?
Well, do you want to continue?
Yeah, so important question, go ahead. Not important. So we continue with the presentation. Yes. Okay, so so far you've seen and I think it's another example. Yes. Sorry, a nicer example. Yes. Okay. So here is a slightly more advanced example. We have an avatar here with a round avatar photo. We have name of a person. We have some kind of description here. another avatar, another person name, another description. So slightly more nice looking, slightly more advanced example. Here's the plain HTML version. Some CSS here. We have a container to center the content in the middle of the view. We have a person class. We have a bunch of tag styling on the tags we're going to put in the person class. So we have a title for the name, we have a p for the description, and we have an image, and I just separate it into lines so it looks nicer in the presentation. Here's the HTML code for that. The container, div ID content, and then we have div class equals person, and then we have the image, the title, and the description, and another person. Okay, kind of obvious how to make this in plain HTML. Let's look at how you can build this in Elm. So first, you have a main function here. If you look almost in the roof, it takes no arguments. First, so we encapsulate everything in a call to the div function. And in this case, we actually use attributes here. So we don't define a style. Instead, we write the styling here directly on this container div. And then we have a list of children. And here, looking at the list of children, it looks like person here is almost like an HTML tag, because that's what you usually saw when you looked in the list of children for a div or an H1 or any kind of Elm HTML node. So the way you build components in Elm is obviously with a function, because it's a functional programming language. But this is how you do it. So basically, you define your own tag almost, and you define the kind of data you need in order to generate the layout for your component. So in this case, person will return one HTML node containing the layout for this person. So let's look at the person function. We have the person function here, 3 arguments: name and the JPEG and description. Another div here that we encapsulated the person in. We have some styling here. And then we have 4 children: image, H2, P. Sorry, that's 3. OK. So the image, we have attributes here. We have a source attribute, which is the URL to the image. That's the way you have images in HTML. We have something called avatar style here. It's located elsewhere in our source code, but I can already tell you now it's to get rounded corners on that avatar. And then we have some specific styling for where this image is being used. We float it to the left, and we add some right margins to not have the text directly joining the avatar image. And no children for that image tag. Then we have the H2. We have some styling here for the font. We have a text children with a name. We have a P paragraph. We have some styling here. We have some text, which is one child, which is a text HTML node with just the text of the description. If you look at the style here, so the attributes is a list of HTML attributes. The style functions return one attribute, in this case the style attribute. And the style function takes one argument, which is the list of tuples in this case. And each item in that in that list is the CSS attribute name and the value. Yes?
Why is it a normal parenthesis and not square brackets for the like the CSS attributes?
So the question is, why is it normal brackets instead of square brackets? You mean?
Yeah, I mean all the other lists are square brackets, right?
Yeah, okay, yeah. So this is not a list. This is a tuple.
Okay.
The parenthesis here and the comma. This is a tuple.
Okay.
And a tuple of the type string, comma string, which if you probably. So I think if you have a different kind of tuple and try to pass it into a function, you'll get a compilation error. Looking at the top of the file, we obviously import the HTML module, exposing everything from there. We import the HTML attributes as well, and we need a style and the src attributes here. And here we have the avatar style, and this is a typo. It should be width and height, but it works. As usually with HTML, sometimes it works even though it's a error in the code. And here's the border radius 50%, which creates these round avatar circles. Yeah, so far I've shown you that Elm is a static template language, which obviously it's not. Elm is made for building interactive web applications. Reliable, delightful. Okay? But in order for you to grasp the next part of the presentation, it's good for you to have the basics. Here's an interactive example. 2 buttons, add and remove. Let's play it. So this interactive Elm application, it has 2 buttons. You're clicking add, you get more happy avatars, and if you click remove, you get less. And the more you add, the bigger the last one becomes. So let's look at the code. We import an HTML module, we have HTML attributes, but we also have something called HTML.events, which is an on-click event here that we will use for the add and remove buttons. Oh, sorry. So the main function here, I lied a bit earlier when I said that the purpose of the main function is to return the HTML nodes of our application. The purpose, and I'm actually lying again, but it's enough for right now. The purpose of the main function is to return continuously the HTML nodes of your application. So when your application is changing, it's returning a new tree of HTML nodes, which is being passed into the DOM, and then there's a virtual DOM comparing previous and current state and applying that to the real DOM. If you've used React or Angular, it's the same kind of thing. So instead of directly going for a div or a h1 tag or something here, we go for the beginner program, and it obviously comes from the HTML module because we're exposing the whole HTML module there. And this beginner program takes 1 argument, which is a record. This is called a record in Elm, and it has 3 fields. It has a model. In this case, our model is super simple. It's only an integer, the number of avatars. In this case, we start with an empty application. There's no happy avatars, 0. Then we specify our update function and our view function. This is how the Elm architecture is described in the Elm documentation. So you have your Elm runtime. It passes messages to your update function, and the update function is also getting your previous state, your previous model, and the purpose of the update function is to return the new model. That new model is being passed to the view function, and the view function basically replaces the main function you had earlier. So the view function returns your HTML nodes this time instead of the main function. So HTML. Going back to the Elm runtime, and if you click on buttons and stuff, you get new messages. That your update function is being called with those messages. It generates a new model. That model is being passed into the view function. That generates new HTML nodes. That goes into the Elm runtime. That compares it with the virtual DOM and adds it to the real DOM. And this is really fast as well. You know about React and Angular, and Elm is at least on par with these technologies. It's actually slightly faster. You can check the details on elmlang.org. But the whole thing of like rendering your whole layout every time actually is fast and a usable way to build websites. Back to the code. We here have a custom type message. It has 2 valid values, add and remove. This is almost like an enum if you program C or other languages that has enum. So the only 2 valid values for a variable of type message is add or remove. So this update function takes a message and the previous model. In this case, the model will be 0 initially when this update is called, because we didn't have any avatars in the beginning. Actually, if you look here, this 0, we set the model initially to 0. So this is being passed as a second argument to the update function. Here we have a case statement. So we are casing the message. It's similar to switch in C++. And we cover the two branches here. First branch, so basically what this means is if message equals add, return model plus 1. If message equals remove, return model minus 1. So basically just increment or decrement our integer, which is our whole state for our whole application. Now if we remove the remove choice here, what happens then? We get a compilation error that says you need to account for the following, add a branch to cover this pattern. So this case does not have branches for all possibilities. So when you're using a type in Elm and when you're using the case statement, you need to cover all different possibilities. You cannot skip anything, because then you're having it's not pure. It's not. It will generate some kind of runtime error, and Elm doesn't generate any runtime errors. So
you don't have any null values.
There are no null values. Yeah, back to the code again. So we have the
question. Elm does never generate runtime errors.
So Elm does not generate runtime errors. There is one kind of error you can get, which is a stack size exceeded, because there's a lot of recursive functions when you're using a functional programming language. But so far in 1 year of Elm in production, 150 customers something using it. There have been no other kind of errors, and those and it has been very rarely this stack size exceeded errors. It was when we added some kind of big time zone module, and obviously it was Internet Explorer that failed, because different browsers had different limits. So we tested it in the incorrect browser in this case. But other than that, we have had no runtime errors. Back to the code of this example. So you saw the main function. You saw the update function, and this is the view function. So the view function replaces the old main function in the early examples. But the difference here, it takes one argument. And it's the model. In this case, it's a simple integer, but the model could be a very big state, the whole state of your application. It could be, think of it as a JSON blob or whatever kind of state you want to have. So it could be really extensive, the model. But in this case, it's a simple integer. So we call div function no attributes, a list of children. Here we have 2 buttons, and here we have attributes. So remember earlier when I said there are attributes and children to the HTML nodes. In the attribute list, you can also specify events that you want to have for a specific HTML node. So in this case, we call the onClick function with the add value from the type, the custom type that we created. There's somebody at the door. If somebody want to go and fetch the door. Yeah. So what this says is when the button is being clicked, generate the message add. When this button is being clicked, generate the message remove. And then we have 2 break rows here. No attributes, no children, because why would you have it on a break row? This is just to get the avatar slightly lower on the screen. And then we call div with no attributes. And here we call div with the result of a function called render here. And render is a function we defined ourselves, 2 arguments, an empty list, and we pass the model in. So, and here at the bottom you can see the Elm architecture again, the message to update to view to runtime and back again. Message, update, view, runtime. So that's how it goes. Let's look at the render function.
But now, sorry, can you go back? feel a little bit stupid here, but in the last div you have normal parentheses again.
So, so the question here is, in the last div here I have normal parentheses. So you haven't seen that many parentheses. When we're making function calls in Elm, you don't need to specify parentheses. So here, div, and you just specify the argument directly, the first argument here. And the second argument is this whole list. So you call the div function with two arguments, one on the first line and then the list on the second line. So there are no parentheses in this function call, the function called the div. Here, because we want the second argument to the div function to be the result of the function called to render. We have to enclose in parentheses that we want the result of this render argument 1, argument 2.
So it's kind of like in mathematics.
Yes,
So-
precedence.
Yeah.
So it's precedence like in mathematics, yes. And so it's only when it's not clear that you need to do it this way.
Cool.
Let's look at the render function. So we take two arguments, progress and I. I is the integer from the model. And then we go directly down here in the body of the function. We skip the labels first. So if I above 0, then take a list with one element, which is an image. And then we join that list double plus. And it's the same if you want to concatenate strings in Elm as well. You use the double plus. And then we call this function again. So this is actually a recursive function. And we call that function, this function, with the previous progress and I minus 1. So basically what this makes is we will get a list with one image for each increment of I. And if it's not above 0, which means it is 0, we just return the progress already. So it's a recursive function that here's where the recursion happens. So image joined with a list here, and this going called again. Image equals potentially here the empty list that was passed initially to progress. So this will, if the I is 7, this will actually be 8 things joined together. 7 lists with an image, and the last list is just empty list. And here we calculate the width we want to have of our avatar with a bit of a exponential function here. And now I'm talking about mathematics. So this is upphöjt till power of 1.7 and times 16 because I wanted to have a head start. And then we have the image function here. And if you see here, this image function takes no arguments. But it's defined here as a label here. And this width function can access I because it comes from the argument of the function. This image can actually access width here that is defined just above it. So the scope you are defining here is accessible within the scope as well. So that's why you don't need to pass any specific arguments down here. So this function is actually being defined for each call to this function. Because image is a different function for each execution of this function. So each execution of the function render has a different image function defined when it starts. That's the life of functional programming. It feels a bit like backward programming, but once you sort of get above a certain threshold, it becomes really fun, and I have had lots of fun programming in Elm. One question.
Yeah, do you unit test the code?
So because we have compilation, statical typing, we don't do any unit testing on the front end. So here again, what we looked at. I have one more example to show you. It's obviously called interactive 2. So let's run it. Once upon a time, there was a man called Evan who liked functional programming, but he was missing something more elegant and tailored towards the web, so he designed Elm. So basically, this Elm application is kind of a vis-a-vis editor. Let's play it again. So you can add a title or a segment or an image. And so the model of this application is a list of elements. Or it's actually not a list of elements, it's actually a list of records defined. So there's one type for title, one type for paragraph, one type for image. This code is slightly larger, so I'm not going to dive too much into detail because we have other presentations coming up as well. But I'll just quickly show you it, so at least you've seen it. So we have type for element. It could be title and it with a string connected to that. So you can define what's called mixed types or union types in Elm. An image has two strings even. It has a URL and it has the alt text. And here we define a type alias. This is a record because when you're using records, it's not like in JSON you can just add and remove stuff. You have to have exactly this. All fields has to be there. You can't skip a field. So the type for a record is actually how it's structured. It's not the name here, model. So as long as you pass in a record with the same kind of setup, the compiler will give no errors. That's why it's called a type alias. Here we have a main beginner's program, model, empty model, update, view. Here we have our empty model, body. This is actually, so why is there a body and not just only the element? The body is the text, the contents of the text area. Here we have the message for this application. We have a reset, it's not being used. We have a new text string. This is a message that's being passed for every character you type in the text area. Add title, add segment, add image. These are the 3 buttons. Update message model, we have next page will show the rest of the branches, because when you're using a case, you need to cover all branches. Reset, it returns empty model. New text S, which is when you're typing. This is how you're changing the model. It's a bit of a weird syntax, but you get used to it. So says like which record you are having initially and which kind of field you want to change. So this returns a new record with everything same except the body. Body is being changed to S here. Add title. So based on model, it changes 2 things here. It changes elements and body here. It resets the body so that the text area is becoming cleaned. And then it takes the old elements and appends a new title here to that list of elements. We have a view, kind of obvious text area, button, button, button. But we also have render our model here. Look at the render function. We look at the bottom here. It's a div, no attributes, and it's a list map. You've seen list map before. So render element for each element. So we will call render element on each item in the elements list. And here you see the render element. I've defined it in the local scope here because it's not needed outside of the render function. Title, segment, image. These are the different branches because the element type can only be of those. And then for title we have an H1. For segment we have a P. For image we have an image. And I'm not actually. No, I actually use title there, desk, and the source URL. And that's how it looked. Again, just a reminder. There you see the 3 buttons. You see the text area that was being changed, connected to the body in the model. I could have talked more about how we've been running Elm when you're in production and a lot of learnings about that. No time for that tonight. There's also an excellent time travel debugger. There are helpful compilation errors. You got to see part of one. I can talk about how update and view pattern suits single-page applications. It worked really well in that kind of context, I'd say. And then talk about more type, subscription, and ports. And ports is how you make JavaScript interop in Elm. I will send a link to a GitHub repo on my Twitter, or you can check GitHub directly, called Elm Intro, where I'll put up the source code. I'll also tweet out the recording of this presentation when that is available as well. You can also reach me on email. And I think maybe we have time for 2 minutes of questions before we dive into the next presentation. So, start here.
What kind of editor are you using?
Me personally?
Yeah.
So I'm a editor agnostic. I try to not be super connected to one editor because I want to be productive even if I have a black and white nano over, or even a VI over a SSH terminal. For this I've been using Visual Studio Code actually, mostly. Yes?
What's the bad parts with Elm?
The bad parts with Elm. I think the barrier of getting to work with functional programming when you are used to imperative programming, it's a big threshold. Once you do get above it, it feels like you're writing the code of your life. But when you're connecting to APIs and backends, you have to validate all data and connect it to representation within Elm with records. So that can be a bit annoying and frustrating. And I talked to my colleague this morning about this, and specifically this question, what the bad parts was in Elm. So that was something he mentioned. Because it's still in the browser, you're not saved from browser quirks. So yeah, there was one thing we had to fix, which was time zone related. If you know about JavaScript, you'd probably know about that anyway. So, and because everything you do in Elm, when you're doing JavaScript interop, you have to pass in the data as messages. So it's not that easy to do interop because Elm is pure and it has to remain pure. So the only way to get things in is through messages, and then there's a way called ports to get it out. So that is maybe, I wouldn't say it's a bad part because it makes Elm safe, but if you have to do a lot of interop with other parts of JavaScript in the same application, it's probably a bit annoying to use.
Thank you for an excellent presentation. I have 2 questions. First, is it possible to define the types in the function?
So the question is if it's possible to define the function signature when you're defining a function. Yes, and it's also recommended to do that, but it takes a lot of screen estate when you're doing a presentation. So I'd say when you're building and prototyping, it's probably nice to not do it. And then once you've stabilized, it makes sense to do that because the type inference could be wrong if you're calling the function. So because when you get an error with type inference, there's the callee and the caller, and depending on how you code and structure and stuff, it could sort of hint that your error messages will be worse if you don't put the function signature. And especially for the model, I'd recommend defining the signature as a type alias, and because it will, and because then you can use that type alias in the function signatures when you're using the model, and then you will get better error messages.
And my second question was, would you recommend learning Elm if you don't know any JavaScript?
So if you don't know JavaScript but know a little bit of HTML, you will have lots of fun working with Elm. You don't need to write a single line of JavaScript code to build excellent Elm applications. So it's actually a very good way to get into web development and single-page web application development without the need to learn or work with JavaScript. One question here, front.
Can it be connected to other languages as well?
If Elm can be connected to other languages, because it runs in the browser, in the JavaScript runtime. If let's say you have React and Redux, or you have Mscripten or something that still runs in the browser, maybe you have Rust compiled with WebAssembly. Of course, because it runs in the browser, you can connect with everything that is in the browser. You probably would need to have some JavaScript glue, but it's possible.
Can you run Elm outside the browser?
So can you run Elm outside of the browser? If you go into the Elm repo, look at tickets, there are a lot of requests for, we want to run Elm on the server. Let us build awesome backend applications in Elm. The JavaScript people have we want to have Elm on the server side as well. The golden rule of API design is, when in doubt, leave it out, because then you put in the stuff that is needed. And if Elm would be forced to work with both the front end and back end at the same time when it's a developing language, it could probably hinder the development of Elm being a very good front end language if they started now to support back end applications. I do think that Elm has a path of actually supporting back end applications and building stuff that is not run in the browser as well. It is possible to use Elm to generate static pages, for instance. There are tool sets for that already. But Evan, who designed Elm, I think he's a very smart guy. And that decision to not rush into server-side or rush outside of the front end or running in the browser is a very good decision. Yes?
I'm assuming that you have to represent all the application state into your model. So is there a trick to make the state more modular or easy to add more stuff?
So yeah, the big sort of challenge, I won't bore all people too much about that tonight, but because we could talk for hours about some of the challenges and what you learn of building big Elm applications. But specifically regarding, so the question is, is it easy to make the module changeable? Is all the application state connected in the model? And yes, all the application state need to be in the model. There are no global variables. So the only data that your function has access to, the only data is the arguments being passed into the function. So in order to use the model, you have to pass the whole model or parts of the model down to the functions that need that data. And in some case, I mean, what the good thing about it is when you're looking at the function, you can know exactly where the data is coming from. There are no hidden spaghetti code. It's really easy to follow the flow where the data is coming from. But it also means when you have big data needs, for some cases you need a lot of data at the same time. It can be a bit complex to understand how to build that scope and how to get it in connection. So I'm going to give you one simple practical example that we experienced, and that's related to translation. Because let's say you want to be able to switch language from English to Swedish. Let's say you have an English and Swedish application that you have in both languages. Each function that is going to show a text in either Swedish or English needs to have access to the language you've chosen from the model, which means you need to pass that along to. So let's say you have like a alt text on an icon somewhere, and you use that on many cases. You need to ensure that every place where that function is being called, you need to ensure that a model is available. So what we decided on is actually not to have dynamically not do dynamic translation. We actually do that at compile time. We compile one bundle which is English and one which is Swedish, because it's made the whole code base much easier to work with. And we did, for that application, we didn't have a need to support fast switching between languages. It was okay to, at the login page, to select English or Swedish, and not be able to change language within the application. But that's one of the challenges you have when you have all state in just a model. Do you have a short final question, or is it time for a JavaScript presentation? I think it is. So thanks for listening.
Thank you, Alice.